Hey yo, Victor here, and I'm pretty sure most of you are familiar with Cheat Engine. For those who don't know, it's actually not just a program to make game cheats. It's actually a really useful tool for reverse engineering, for debugging, and for actually inspecting memory and writing to it. So what I've been working on a library called EmuHook, which is this one here. It's actually a common library to actually access the emulated memory from games. Some of the projects that I've done with it are like a multiplayer mod for Pokemon Crystal, various dynamic real-time overlays that actually show in-game data, auto splitters, more multiplayers, a Pokemon bank, data mining tools for Pokemon, and many more. So the thing is that I was showcasing some of the stuff that I'm doing lately. Let me see, which one was it? It was Lazy Hunter, if I recall correctly, which is great channel, by the way. He uploads really cool stuff. So I was actually showcasing integration with GB Studio because I wanted to break the fourth wall and actually make Game Boy games to actually interact with your OS. Like for example, that you go to a post sign and that post sign is going to tell you, hey, I see that you live here and the temperature is actually this. Or I see that one of your recent files was this PDF. So it's kind of scary, but I think that it was like a cool concept for breaking the fourth wall. So yeah, Real 96 actually asked, what about a RAM watch? Why you're actually showing RAM, but how about creating a tool that actually searches for values inside of the RAM? Well, this is actually what I have been doing today. I will be doing a little demo on two different emulators. I'm going to be using a Game Boy Advance emulator and a PlayStation 1 emulator. So while I show you that, I've got two tools that you may like, which is, well, first of all, let me show you the config. So this is the config files that my memory viewers actually take. So you first search for those memory addresses either online or using Cheat Engine, and then you just make a file like this one, and you can do some things like this. You can actually make a memory viewer, or you can actually integrate it with other tools, because there is a TCP version that you can integrate with Python, Java, JavaScript, whatever language that actually supports HTTP, TCP sockets, or WebSockets. So you're pretty much covered. So these programs are actually made in AutoHotkey. I know it's not a very well-known language, but I just like it too much. And so today, let's go straight to the point. I started working in a cheat engine clone. Well, making a cheat engine clone may be a huge overstatement, but let's call it like a cheat engine mini. So basically it's actually focused on emulators. So let me show you these panels, what they actually do. So as you can see, I've got 35 fastballs, but if I toss 11, as you can see here, I see 35, and here I can see 35. If I toss 11, as you can see right now, I have here 24, and this updated to 24, and this updated to 24. I can set this one for 299, for example, and it will update in game. But let's pretend that we do not know these addresses, these magic addresses. We have to find them ourselves. So some emulators actually have a search for cheats or a memory viewer function, but some others do not, and EmuHook actually addresses that. For example, if I recall correctly, Gambate speedrun, of course, it's a speedrun tool. It doesn't have a memory viewer, but we can actually use EmuHook to have a memory viewer there, or to make integrations. For example, let's say that if we find a shiny Pokemon, we want to receive a WhatsApp or a Telegram notification, we can actually do that with this. If I recall correctly, Azar, Semu, well, maybe Semu? No, I think it doesn't have a cheat menu. But, I mean, we can create one with this. So that's what we are going to be doing right now. Let's go with, let's try to make one. For example, for the love balls, we have 35 love balls. And we can just find the process of Visual Boy Advance. This is a GBC game. Okay. Let's find an exact of 35. We got these values. Let's throw like 3 of them. So we now have 32. If we go search for 32, we have these values right here. If we continue to rescan the memory, let's go to another area. As you can see, this is the memory address that we are actually keeping track of. So let's set this to 65, for example, and it should update. Yeah, if we rescan the memory, you can see that it updated. Yeah, I think that's pretty much a small demo on how you can use this. One of the things that you can do is that if you know how the memory structure of a console works, you can actually make an offset and make a guess that it's going to appear between Z000 and E000 in this case, because the Game Boy Color only has 8 kilobytes of RAM. So we can just set this size to 1, which is actually 8 kilobytes. And we can search for 65 again. So let's search from 0, Z000, first scan. And as you can see, it was way faster because we are not looking at that many addresses. And right now I'm going to be doing, as you can see, it updated here too. And right now I'm going to be doing a demo with a really not really known game, unless you are in the Resident Evil communities or you have watched a video about it. This is Resident Evil 1.5, and we are going to be making cheats for it. So I've got this one, which is for Leon's HP, and I know that Leon's HP address is in this memory address space. So if I drag and drop this thing, we can see that Leon's memory health value is 100. So let's set this to like 1, and as you can see, health changes here. If we set it to 50, it changes to caution. If we set it to 100 once again, it's we are back into the fine state. So let's try to find the address value for I don't know why I closed this, but let's try to find the value for our handgun. So we know we have 15 bullets, so let's go with 15, and we are going to find Duck Station. So let's go with Duck Station. This is a PS1 game. We can set it to PSX or PS1. It's going to pick it anyways. And we are not going to be setting an offset, so we're going just to offset from 0, 0. So let's try to find it. And of course, we want to have a wider search. So instead of the size being 8, we are going to set it to 128. This is going to be taking more. Now, remember, AutoHotkey is not a really fast language. This is actually something that you shouldn't do. You should be using like any other language, not AutoHotkey. But we are doing this because we can, and because I like the language, anyways. So let's begin the search. As you can see, it's taking in more because it's actually doing 8 times 1024 by 1,000 results. Yeah, it's doing actually 8,192,000 searches. So let me see if I'm actually making the it's correct what I'm doing. Yeah, I cannot because yeah, I cannot. I can calculate this. So these are the values that are actually 15. So if I refresh the memory, it will go down a bit because memory changes from time to time. So let's try to shoot. So we should have 14 bullets now. So let's go to well, we can go to exact. Yeah, this is the memory value that we want. So we have 14 bullets right now, but if I set this to 95, for example, we can see that we have 95 bullets. Okay. Other things that we can do. Let's pretend that I do not know my health value. So let's wait. Let's start with an offset of A0000 and with 32 bytes. So we do not know our HP. So let's go with unknown and first search. This is going to be taking a while, so I'm going to stop. Is it not post? Yeah, it didn't post. Well, I have to post it in post. Okay. So it's almost finished. Yeah. These are each and every value. And we actually know that our HP didn't change. So let's set this to compare with the previous value and set it to unchanged. So next search. So it's taking it a while. I'm going to pause here and we will continue. Alright, so let's now take some damage. So we now know that our health value should have decreased. Now I can see it here. I know it's 85, but let's pretend that we do not know that address. So let's go with changed. No, it's actually smaller than the previous, so let's go with smaller. So it now doesn't take that much. And as you can see, we've got these many values. So let's go once again with unchanged. Again, yeah. Let's try to take more damage and see if... yeah. So we now should have a smaller value. Yeah, so these are the ones. Let's see if we have it. So yeah, it's this one, but let's pretend we do not know. Let's take damage once again. So first of all, we know that it hasn't changed. So let's go with unchanged. And we can see that the addresses are actually... oh, no way. No way, yeah. Let's go for decreased. Yeah, we have those values. So one of those is actually the one we are interested in. Since we have that, we can just click on refresh. We know it's 6, 55, and 55. So let's refresh, and we've got 2 addresses for the HP because this one is not smaller. It's not smaller. So let's go with 40 now, and let's go with exact. So one of these 2 is the memory address for the health. So I know it's this one, but let's try to change this one. So I set it to 80, and as you can see, the caution is still in yellow, so that's not the value that we want. So let's set this one to 80, and yeah, it changed to fine. So this is our health value. So if we take damage, we can keep taking damage, and just update that and see if it changes. Yeah, so we can see that both memories are actually linked together, but the actual address that controls our health value is this one, as you can see. So yeah, just like that. So if I take one hit now, I should just die. Yeah. And yeah, I hope you liked this video. Hope it didn't turn out too long. So see you around, and I will be posting updates on new tools that I will be doing about EmuHook in the next few days. Bye.